Dear students, in the last class I have explained the important equation related to capacity of a parallel plate capacitor, which is given by C is equal to A epsilon naught epsilon R by D, where A is the area of the plate, epsilon naught is a constant called permittivity of free space, whose value is 8.854 × 10⁻⁻12 farad per meter. Epsilon R is a dielectric constant of the medium between the plates, and D is the distance between the plates. And what is the use of the capacitor? Capacitor is used to store charge and energy. How to store charge and energy, and what is the expression for that energy stored in a capacitor? Important question. So, it has appeared 4 times in the examination. To charge a capacitor, you need to connect the capacitor. So, symbol used for the capacitor is 2 lines, straight lines, parallel lines of equal length, because if their length are not equal, then it becomes a symbol of some other device, which is a cell or a battery. So, capacitor symbol is 2 parallel straight lines of the same length. Okay. When connected to a battery with a switch like this, initially, when the capacitor is uncharged, its charge is 0, no charge, because it is uncharged capacitor. When there is no charge, what is the potential difference across it? That is also 0. What is the capacity? That is a C. Okay. Now, once we close the switch, this particular terminal of the battery, which is positive terminal, attracts all the electron from this plate. So, electrons, they start moving like this, and once it loses electron, it becomes positively charged. And those electrons which are accepted by the battery is transferred to the other plate, so that other becomes negatively charged. So, the charge on the capacitor slowly increases. Okay. From 0, it slowly increases. Potential difference also increases. But capacity is a constant, so it will remain C only. Capacity will not increase. Capacity is a fixed constant for a given device. So, when this process of charging stops, when the potential difference between the plates is equal to the potential difference of the battery. If the potential difference of the battery is a V, and that is equal to 10 volt, then the potential difference across the capacitor also becomes a 10 volt. Now, this is called fully charging a device. Normally, you get to see, while charging the mobile batteries, correct? So, there is a percentage. 0, percentage increases, and it's 100%. Once it is 100% means now it is fully charged. You can't charge beyond that. The same thing here, you cannot charge the capacitor beyond this voltage. If this is 10 volt, you can charge to 10 volt only. If this is a 50 volt, then you can charge to 50 volt only. Understood? So, the charge increases. Let me consider the final charge, let it be Q, capital Q. The final, okay, on both the plates. So, on one it is plus Q and other is minus Q. This is after it is fully charged. Let the potential difference be V. So, that what is the relation between these 3? The relation is C is equal to Q by V. Now, during the charging, so listen carefully, during the charging, at a particular instant, let small q be the charge. What is capital Q? It is the charge once it is fully charged. What is small q? It is the charge at a particular instant. At that instant, let the potential difference be V dash. Capacity is a C. Now, what is the relation between this? The relation between those three is a C is equal to Q by V dash, or that implies a V dash is equal to Q by C. Now, at this instant, let a very small amount of the charge dq is further transferred by the battery. Already q is there, in addition to q there, an extra charge of dq is transferred, a very small amount of the charge at this instant, when the potential is V dash. So, what is the work done by the battery in transferring the charge? So, it is the battery which does this work. So, work done by the battery is given by dW, very small work done, into the charge transferred. What is the charge transferred? It is a dq, into what is the potential difference at that instant? It is a V dash. Okay. And from where do we get this equation? We get this from the earlier discussion, which is work done is equal to the charge moved into the potential difference. So, hope you remember this formula from our earlier discussion. Work done is equal to the charge moved. So, work done is a dW, charge moved is a dq, potential difference is a V dash. That is equal to dq into what is the V dash from here? Q by C. Q by C. So, that is a Q by C into dq. So, that is dW. So, this is a small work done by the battery in transferring a small amount of charge dq. But our aim is to find the total work done by the battery to transfer a charge from 0 to q, total. So, how do we measure that? By using the mathematical form, which is integration. So, W is equal to integration of 0 to q, that is the limit 0 to q of dW, that is 0 to q. dW is nothing but q by c into dq. 1 by c is a constant right outside. Integration 0 to q, q dq, q into dq. This integration is of the form integration of x dx. Integration of x dx is nothing but, here it is x square by 2. Integration of x dx is nothing but x square by 2. So, that is using the general formula, x to the power n dx is equal to x to the power n plus 1 by n plus 1. So, here n is 1. So, 1 plus 1 becomes a 2 here, and then again this becomes 2. So, therefore, now 1 by c into integration of q dq is nothing but q square by 2. This is x dx, it is a q dq, correct, q square by 2, and then the limits. Now, substitute the limits into, replace q by this capital Q square by 2 minus the other limit is 0. Fine. So, we have found the expression for the total work done. So, the expression for the total work done? The total work done is given by W is equal to half Q square by C. See, here it is, half, 1 by 2 is there, half Q square by C, correct. And this work done is stored as energy. So, therefore, U itself is equal to W, therefore, U is equal to half Q square by C is one of the formula for energy stored in a capacitor. Are you clear? But we also know that C is equal to Q by V, correct? Capital C is equal to capital Q by V. So, replace half, then we have Q square by C can be replaced as Q by V. C can be replaced as Q by V. This one of the Q will get cancelled. So we'll get one more form, which is half QV. Okay. So next we get one more form, that is from this Q is equal to CV. So that you can replace here. Okay. It's a half. Q is nothing but CV. CV into V. So we'll get half CV square. Half CV square. So therefore, finally we have derived expression for work done and then the energy stored in a capacitor. So what is the formula for energy stored in a capacitor? There are three formats are there. Which are those three formats? The first one, U is equal to half Q square by C. U is equal to half QV and is equal to half CV square. Are you clear with this? So three expressions and all. U is equal to half Q square by C. U is equal to half QV and U is equal to half CV square. Okay. Right. Now, based on all these equations so that we arrived, so let's try some numericals. Okay. Right. This is the first question from the exam. In a circular parallel plate capacitor, radius of each plate is 5 centimeter. So radius is given 5 centimeter. Conversion is important. 5 into 10 to the power minus 2 meter. Centimeter to meter. And since it is a circular plate, I can always find the area. What is the area of a circular plate? Pi r square. Pi is 3.142 into r square. R square of this, so that will be 25 into 10 to the power minus 4 meter square. Now that is the area. They are separated by distance of 2 millimeters. So separation between the plates is a 2 millimeter. Conversion 2 into 10 to the power minus 3 meter. Okay. Calculate the capacitance. So we have to find the value of C and then the energy stored, calculate the capacitance and the energy stored when it is a charge by connecting the battery of 200 volt. Okay. So V is given, which is 200 volt. And the value of epsilon naught is also given. So that is a constant. Epsilon naught 8.854 into 10 to the power minus 12 farad per meter. So first we'll find the capacitance. Formula for capacitance, C is equal to A epsilon naught. See, regarding the dielectric medium, they haven't mentioned anything. That means when there is no medium is mentioned in the numerical, so we have to assume that the space is filled with air or vacuum, for which the value of epsilon r is 1. So therefore, C is equal to A epsilon naught, epsilon r, which is 1 by D. What the value be? A is here 3.142 into 25 into 10 to the power minus 4. Now that is A. What the value of epsilon naught? 8.854 into 10 to the power minus 12 divided by what the value of D? D is here 2 millimeter, which is a 2 into 10 to the power minus 3. So let's calculate using the calculator. So what is the value of this answer? 3.142 into 25 to the power minus 4, correct, into 8.854 to the power minus 12 divided by 2 to the power minus 3, correct? Yes. Now that value comes out to be 3.477 into 10 to the power minus 11. Now that is the capacity. What is the SI unit of capacity? It is farad. Capital F is the symbol used for that. So we have found a capacitor. Now how to find the energy? So energy is given by U is equal to half. See, we know the value of V and C. So that's why I'll use that format. U is equal to half CV square. Half CV square. Half. The value of C? C is here. 3.477. 3.477 into 10 to the power minus 11 into the value of V. V is a 200. 200 square. Okay. 200 square of it. So let us simplify this. That's first it is 0.5, then into 3.477 to the power minus 11, then into 200 square. Okay, so we will get 6.954 into 10 to the power minus 7. We are finding the energy, right? So what is the SI unit of energy? Energy is measured in joule. So that is the answer for it. Okay. So a very easy question, direct substitution. So you have to remember expression for capacity of a parallel plate capacitor and the expression for energy stored. You have to remember all the format of the energy stored. Which are those three formats? U is equal to half Q square by C, U is equal to half QV, U is equal to half CV square are the formats of the equation. Okay. So hope you have understood this particular numerical from the examination. Okay. So let's try one more question. Right. So same question has appeared 3 times, and again when we say 3 times, there is a possibility of just change of values. Okay. The problem is the same, only data they will change. So that's why this particular question is important. It has appeared even in the supplementary this year. Okay. So let's go through the statement now. So first one, in a parallel plate capacitor with air between the plates. So medium is given, air between the plates. Each plate has an area. So area is given here directly, which is 8 into 10 to the power minus 3 meters square. That is the area. And the distance between the plates is 2 millimeter. So separation between them is symbol D, 2 millimeter. Conversion again important, 2 into 10 to the power minus 3 meter, millimeter. 1 milli is nothing but 10 to the power minus 3 meter. Calculate the capacitance of the capacitor. So constant A given, I will write that epsilon naught 8.854 into 10 to the power minus 12 farad per meter. Okay. So first we will calculate capacitance. Okay. Then we will come back to the rest of the data. So capacitance is A epsilon naught by D. The value of A is 8 into 10 to the power minus 3. The value of epsilon naught 8.854 into 10 to the power minus 12 divided by the value of D, which is 2 into 10 to the power minus 3. Okay. So the value first 8 to the power minus 3 and then into 8.854 to the power minus 12 divided by 2 to the power minus 3. So the answer comes out 3.542 into 10 to the power minus 11 farad. So that's the capacitance. So that is the first part of the calculation. All right. Now if this capacitor is connected to a 50 volt supply, so V is given 50 volt supply, what is the charge on each plate of the capacitor? Right. So V is given, they have asked what is the charge. For charge we use the capital Q. Right. So what is the charge? Q is equal to CV. Right. So that's the formula. Q is equal to CV. The value of C is here 3.542 in 10 to the power minus 11 into the value of V, which is a 50. Right. So for this answer I need to multiply by 50, then we get 1.770 into 10 to the power minus 9. When we rearrange, 1.770 into 10 to the power minus 9. Now charge, it is in coulomb. You can even write like this, 1.770 into, sorry, that's equal to, this 10 to the power minus 9 is nothing but nano, right? You can write nano. Okay. So what is the charge on each plate of the capacitor? So we have found even the charge also. If they ask energy, you can use that formula, correct? Half CV square, half QV, half Q square by C. Any of the formula you can use it to find the energy stored. Very easy, you can see. Only a lot of statements are there, but basically it's a direct substitution problem. Okay. So hope you have understood this particular question. So let's try one more numerical related to this topic. So this is either a 2 marks or 3 marks question. That is, a capacitor of capacitance C is given, which is 2 microfarad. 2 into 10 to the power minus 6 farad is charged to a potential difference of V is equal to 10 volt. Okay. Calculate the energy stored. Isn't it easy problem? It's a 2 or 3 marks question. So, half CV square is the format because C and V are given. Half C value 2 into 10 to the power minus 6 into V is a 10 square, which is 100. So, this 2 will get cancelled. 10 to the power 2, 100 is nothing but 10 to the power 2 in 10 to the power minus 4 is 10 to the power minus 6. 10 to the power 2 and 10 to the power minus 6 is nothing but 10 to the power minus 4. So, that is it. So, that is the energy. What is the unit? SI unit. It is in joule. See how easy numericals are. So, only when you practice, then you will be able to answer all these kind of questions in the exam very easily, provided you know to which chapter this question belong to and what are the equation to be used, right. So study. So, let us go through one more question, again from the exam only. The plates of a parallel plate capacitor have an area of 100 centimeters square. So, area is given 100 centimeters square. 100 centimeter is 10 to the power minus 2 conversion. Square of it 100 is 10 to the power 2. 10 to the power minus 2 into 2 is not 10 to the power minus 4, and that will give you 10 to the power minus 2 meters square. See the conversion involved. If you do not do this conversion and if you substitute the value directly, you will get wrong answer, correct. So, you will get only 1 mark maybe if you write proper equation, otherwise you will get 0. So, wherever conversion is required, you have to do it properly, and then it is given that they are separated by 3 millimeters. So, D is a 3 millimeter. So, again you can see one more conversion, 3 in 10 to the power minus 3 meter. The capacitor is charged by connecting it to a 400 volt supply. So, V is given 400 volt. Calculate, first option, the energy stored in the capacitor. To find the energy stored, I have to calculate capacitance. So, we will do that first. C is equal to A epsilon naught by D. The value of V 10 to the power minus 2. The value of epsilon naught 8.854 in 10 to the power minus 12. So, they will normally give this constant. Let us check whether it is a given. If it is not a given, then obviously you have to use that constant. Okay, so here the constant is not given. Do remember this 8.854 into the power minus 12. Then divide by the value of D. D is here 3 into 10 to the power minus 3. So, what is the value of the capacitance? So, we have first 10 to the power minus 2 into 8.854 in 10 to the power minus 12 divided by 3 to the power minus 3. So, we will get 2.951 in 10 to the power minus 11 farad. Now, that is the capacitance. How to find the energy stored? Option A, U is equal to half CV square. It is a half the value of C 2.951 in 10 to the power minus 11 into the value of V. V is a 400 square of it, 400 square. So, that is 0.5 into 2.951 to the power minus 11 into 400, again into 400. So, we will get that 2.361 into 10 to the power minus 6 joule. Now, that is the value of the energy stored in the capacitor. Now, that is choice A. Let us try the remaining. What is that? If a dielectric constant 2.5 is introduced between the plates of the capacitor, then find the energy stored and also the change in the energy stored in it. Option B. See, when dielectric is introduced, capacitance changes. So, what are the new capacitance? Capacitance in a medium is equal to epsilon r into capacitance in air, correct. So, in the last class we have given it, epsilon r is equal to Cm by Ca was the formula used. So, what is epsilon r here? It is a given, a constant of 2.5, dielectric constant 2.5 into, what is the capacitance in air? Capacitance in air is here. See, this is the capacitance in air, which is 2.951 in 10 to the power minus 11, 10 to the power minus 11. Okay. So, let us find this new capacitance now. That is 2.5 into 2.951 to the power minus 11. and we will get that value to be equal to 7.3775 into 10 to the power minus 11. So, this is the new capacitance in farad. So, now we have to find the energy stored and the change in the energy. So, how to find the energy stored? New energy will calculate, okay, energy in a medium. It is a half Cm V square, half Cm and then V square. Half Cm is the new capacitance, right, and then V square. Half into, what is the value of Cm? Cm is here 7.3775 into 10 to the power minus 11. That is the new value of Cm, okay, and then the value of V, which is 400 square. So, what is the new value of the energy? So, that is 2.361 to the power minus 6, which was here. To this I can multiply by 2.5, where we will get that same answer, which is 5.903 into 10 to the power minus 6 joule. So, this is the new value of energy. But they have asked what is the change in the energy. So, I have to find um minus u. Um minus u is the change in the energy, okay, which is 5.903 minus 2.361 is a 3.542. 3.542 in 10 to the power minus 6 joule is the answer, which is the change in the energy stored in the capacitor. So, all these numericals are important. So, that is why there is a need to practice these numericals, students. They are all easy problem, direct substitution, they are not difficult problems. So, just practice these problems, and just a reminder that tomorrow there will be an interactive session at 11 to 12, okay, 11 a.m. till 12 noon, and it will be on Zoom app. So, that is why download the Zoom app and be ready at 11. Just 5 minutes prior to that, the link to the meeting will be provided, okay. And the day after tomorrow there will be a test and all the pattern that I am going to explain in that Zoom session, okay. Thank you.